All right, they're asking us to prove some increasingly nasty trig identities here. 1 plus tan squared a equals secant squared a. Maybe. We'll see if this is actually true. And the basic identities they're talking about are that the sine of an angle is y over r. The cosine of an angle is the x-coordinate over the radius. And the tangent of an angle is the slope. It's the y over the x. So, if we use those here, we've got 1 plus, tangent squared would be y over x, all squared, and that equals, now what do we do for secant? Secant is the reciprocal of cosine, so if cosine is x over r, then secant would be r over x. You can write 1 over x over r if you really want to. I don't recommend it. Those 3-level fractions are miserable to work with. It's easier to just flip cosine upside down. So now if we clean this up, we have 1 plus y squared over x squared equals r squared over x squared. I want to make these two sides identical. The first idea that I have, I'm not positive this is going to work, but if we get a common denominator on the left-hand side, that may help us out. So we can write 1 as x squared over x squared. And then we have our y squared over x squared equals r squared over x squared. Now, we combine these, and we get a single fraction on each side. X squared plus y squared all over x squared equals r squared over x squared. And now we have to make an appeal to the Pythagorean theorem, or what you're going to know soon as the Pythagorean identity. If we have one of our triangles sitting there, and it's got an x-coordinate like so, and a y-coordinate like so, these are always right triangles, and so the Pythagorean theorem always holds, and it tells us that x squared plus y squared equals r squared. We can take this x squared plus y squared piece here and say that's equivalent to r squared, and when we do, we get r squared over x squared equals r squared over x squared, and there's our identity proven. So the new piece that we needed here for the first time is this. X squared plus y squared equals r squared. Because the triangles we're using in these identities are always right triangles, this is always going to hold.